Okay, start class, sir.
Okay, thank you, sir. Good morning, student. My name is Venkateshwarlu, chemistry faculty in Keesaragutta. Today we are discussing the topic of the states of matter. First of all, in this topic, we are discussing about the contents of in first year chapter 4 states of matter. In this chapter, we learn the contents of first of all introduction, and second one intermolecular forces, and next one hydrogen bond, and next thermal energy, the gas state, gas laws, and Graham law of diffusion, Dalton's law of partial pressure, kinetic molecular theory of gases, and behavior of real gases, and compressibility factor in the states of matter topic, students. Stuck అయిందబ్బా తీసేది స్పాట్లైట్ తీసే అదే రావాలి మనకి first start the topic states of matter in the introduction. In lower sections we are already discussed the states of matter, already lower section studied. How many types of states of matter? The matter can be divided into three types. They are solid state, liquid state, and gaseous state. In solid state, all the particles are close to each other. All the particles, for example, ice is the solid state. In liquid state, the particles are nearer. That is the liquid state. We are know about what is liquid. Water is the liquid state. And third one is the gas state. All the particles are free state. That is water vapor. For example, here look at these students, where ice to liquid, liquid to water vapor. And next one, intermolecular forces. What are the means of the intermolecular forces? But students, here look at this. Intermolecular forces means, what is the definition of intermolecular forces? The force of attraction and repulsion between the interacting particles, that is atoms or molecules, is known as intermolecular forces. Here look at these students once again. What is mean by intermolecular forces? The force of attraction between force of attraction and repulsion between the interacting particles. That particles are maybe atoms or molecules. These are called intermolecular forces. These intermolecular forces, it is exist between the two oppositely charged ions. That is, one is the, what is mean by here two oppositely charged ions? One is the positive charge, another one is the negative charge. What is here? Positive charge is cation and negative charge is anion. Here it is, look at this. It is exist between the two oppositely charged ions and the force that holds atom of a molecule together. That means it is nothing but the covalent bonds. The force of attraction between two oppositely charged ions. One is the cation, another one is the anion. That is nothing but is covalent bonds. The attractive intermolecular forces are known as van der Waals forces. What is mean by here intermolecular forces? The attractive intermolecular forces are known as van der Waals forces. Next, look at these students. Types of van der Waals forces. It is the very important in the states of matter. How many types of intermolecular forces? Here 5 types of the intermolecular, that is van der Waals forces. Here look at this. First one is the ion dipole forces. First discuss the ion dipole forces. Here look at these students. Here what is the force here? One is the ion, another one is the dipole. What is mean by dipole? Here dipole means poles. Poles means charges. That is dipole, two poles, two charges. One is the positive charge, another one is the negative charge. Here look at the definition of the, what is the force of ion and dipole forces? Here look at this. The force of attraction between ions and dipoles are known as ion dipole forces. Once again, student, the force of attraction between ions and dipoles are known as ion dipole forces. Ion and dipole means polar molecules are the dipoles. You all understand, students? Here, what is mean by here dipoles? Polar molecules are the dipoles. Here, ions. That ion may be cation or anion. Here, look at the example. For example, we are taking as the Cl minus anion. Another one is the polar molecule. What is the polar molecule? What pole means? Charges. HCl is the polar molecule. Here look at this HCl, H plus and Cl minus. Here look at this in the arrow mark. We can see that it is that electron density, which is the side, the more electronegative side, moving on the more electronegative side. Here ion Cl minus and then the polar molecule is HCl. The force of attraction. Here look at the student. What is the force of attraction here? One is the positive charge and another one is the negative charge. Two ions are forces. Here look at this. Here Cl minus and delta H plus. What is mean by delta H plus? Partially positive charge. The force of attraction between Cl minus and H plus ion. That is the one is the ion, another one the polar molecule. That is dipole molecule. This force is called ion dipole forces. Another example is taking the NaCl, decomposition of Na plus plus Cl minus. Here Na plus in the aqueous state and Cl minus in the aqueous. Here look at this, students, where cation Na plus is binding with the water molecules. Here all are the water molecules H2O and H2O, H2O. In this H2O molecule, the arrow mark is moving on which side? Where oxygen is the negative charge, hydrogen is the positive charge. What is here? Which is the more electron density here? Oxygen is the more electron density. So it is having the negative charge. So the electrons moving on the negative charge. Here Na plus binding with O minus. Here Na plus O minus. Here Na plus delta O minus, Na plus delta O minus, Na plus delta O minus, here Na plus delta O minus. The bonding is formed here. That formation is called ion dipole forces. It is the first one, student. What is the first one? Ion dipole forces. What is mean by ion dipole forces? The force of attraction between ions and dipoles. Here dipole is nothing but polar molecule. Okay, understand, student? And second one, dipole forces. Here look at the students. What is mean here? Dipole and dipole, both are the polar molecules. The interaction between polar molecules and polar molecules, that force of attraction is called dipole forces. In the look at this, the interaction between dipole and dipole. Here one dipole and dipole. What are the molecules? These are the polar and polar molecules. Look at the example, students. These are the dipole forces are the permanent dipoles. That means both are the HCl molecules. We are taking the one is the polar molecule HCl and second one is also HCl. The force of attraction between the two polar molecules, that is called dipole interaction. Here look at the student. HCl taking H plus and Cl, delta H plus and delta minus. Which is side here? Look at this. Which is the negative? Here Cl minus is the negative charge, where H is the positive charge. More charge density towards chlorine side. That means negative electron side. Here negative charge electron is the electron density is the moving here. Look at this polar molecule HCl and HCl. The force of attraction between the, which is the force of attraction here? One is the Cl minus, another one is the H plus. These two are involved in the bonding. force of attraction between Cl minus and H plus. Here look at this. That is the dipole-dipole interaction between the two HCl molecules. In this dipole-dipole interaction, the particle charge are always less than the unit electronic charge. What is the electronic charge here? 1.6 into 10 to the power minus 19 coulombs. What is, students, here? In a dipole-dipole, all partial charge is always the unit electronic charge. That value is 1.6 into 10 to the power minus 19 coulombs. This is the second one, student. What is the third type here? Ion induced dipole. Here look at this, ion and induced dipole. Induced dipole means non-polar molecules. You can understand, student? What is the third forces here? Ion and induced dipole interaction. What is here? The force of attraction between ions and non-polar molecules. What are the non-polar molecules? That means there is no poles. Here look at this non-polar molecule example here. H2, N2, O2, CCl4 and so on. Here ions and charge, here look at this. What is the ion? You are taking the, for example, you are taking the bromine minus and induced dipole here non-polar molecule is taking the H2 ion. Here H2, it is a partially charged. It is breaking into H plus and H minus. The force of attraction between Br minus and H plus, that is called ion induced dipole. That is the third interaction, student. Okay, you can understand what is the third one? Ion induced dipole interaction. What is ion induced dipole interaction? The force of attraction between ion and non-polar molecules. What are non-polar molecules? H2, N2, O2 and CCl4. Here ion, what is the ion here taking here? Br minus is the ion. What is non-polar molecule? H2 or N2, anyone. We can take the anyone, maybe H2 or N2 or O2 or CCl4. The force of attraction between ion Br minus and non-polar molecule H2. And what is the next one? Fourth one, dipole induced dipole interaction. We know that what is mean by dipole? Dipole means polar molecules. Here induced dipole means non-polar molecule. Here look at this, what is the interaction? The interaction between the polar molecules and non-polar molecules. What is, students, here? The interaction between polar and non-polar molecules. That is the force of attraction. What is here? Dipole and induced dipole interaction. Mark to spotlight. Okay, student, what is the fourth one here? Dipole and induced dipole interaction. What is the definition here? The interaction between dipole and non-polar molecules. That is polar molecules and non-polar molecules. Here look at the example. Here dipoles are the permanent dipoles. Here polar molecules is permanent. Here non-polar is the temporary dipoles. Here look at this. We are taking the AB and molecule. Here non-polar molecule. A is the partially positive charge and B is the partially negative charge. Next. Next page. Side note Mouse తీసుకో. Stuck అయింది. Stuck అవుతుంది. Look at the example, students, here, where HCl and H2 molecule. Here HCl, dipole polar molecule, and individual dipole means non-polar molecule. What is the non-polar molecules here? H2, N2, O2, and CCl4. Anyone? Here dipolar molecule is HCl. Here look at this, the electron density moving towards the negative side. Here non-polar molecules, here look at the force of attraction between here Cl minus and here H plus ions. That is called dipole and induced dipole interaction. And fifth one and last one, dispersion forces or London forces. Here look at this, students, here. What is here? Dispersion forces or London forces. The force of attraction between induced dipole and induced dipole interaction is known as London forces. What is here? Dispersion forces or London forces means the force of attraction between induced dipole and induced dipole. That means interaction between the non-polar molecules and non-polar molecules. That is it is also called as dispersion forces or London forces. Here look at this. In a dispersion forces, the electrons are having instantaneously to create a dipoles. That means what is mean? It is also called instantaneous. What is mean here? Instantaneous, immediately form or immediately create a new bond. That is called instantaneous. Here look at this. In a dispersion forces, the electrons are having instantaneously to create a dipoles. That means formation of bond. We know that how to form a bond having the positive and negative charge of ions. Okay, understand, students? In a dispersion forces, the electrons are having instantaneously to create a dipoles. It is also called as instantaneous dipoles. These are the temporary dipoles. What are the temporary dipoles? Non-polar molecules are the temporary dipoles. The temporary dipoles of a, look at these, students, we are taking the example, the temporary dipoles of atom A and atom B attract each other. Atom A and atom B attract each other. Similarly, temporary dipoles are induced in the molecules. Here look at this, taking the air. Atom A with the instantaneous dipole having the positive and negative charge. Atom B with the induced dipole having the positive and negative charge. The force of attraction between the air, atom A and atom B instantaneously to create a dipoles. That is called dispersion forces or London forces. Here look at this example, students. They are taking the H2 and H2 molecule. Both are the non-polar molecules. These non-polar molecules instantaneously create a dipoles. Okay, students, understand? These five are the intermolecular or van der Waals forces. What are the types of van der Waals forces? Van der Waals forces are the five types. They are, what is the first one? Ion and dipole interaction. And second one is dipole forces. And third one is the ion induced dipole interaction. And fourth one is the dipole induced dipole interaction. And last one, what is the fifth one? Dispersion forces or London forces. These are the intermolecular forces are types of the van der Waals forces. Okay, you can understand, student? And next, what is the next? Yeah, next, look at this, hydrogen bond. What is mean by hydrogen bond? In previous class, in a chemical bonding, already we can learn what is mean by hydrogen bond and how many types of the hydrogen bond. Yeah, look at this. What is mean by hydrogen bond? Definition here, look at this. Hydrogen bond is may be defined as electrostatic attraction between the positively charged hydrogen atom in a molecule and negatively charged electronegative atom of the same or another molecule. What is mean by hydrogen bond, students? Hydrogen bond may be defined as the electrostatic attraction between the partially positive charge of hydrogen atom and negatively charged molecules. What is the negative charged molecules here? HF, NH3, H2O, and so on. These are called hydrogen bond. Yeah, look at this. Look at the example here. Formation of HF and NH3 and H2O. Here HF, hydrogen is the partially positive charge. Fluorine is the partially negative charge. What is mean the electrostatic force of attraction between the positive charge of hydrogen and negative charge of another atoms? That is the negative charge. What are the negative charge of ions here? F minus or N minus or oxygen minus and so on. Look at the example here. HF, we are taking the HF and HF molecule. Here, look at the student. The force of attraction. What is the here force here? F minus and H plus. The hydrogen electrostatic attraction between the F minus and H plus. Hydrogen bond is denoted by dotted lines. Students understand? What is the here hydrogen bond denoted? Hydrogen bond is denoted by a dotted lines. It is the hydrogen bond. The types of hydrogen bond are already we can learn in the chemical bonding topic. And next one, student, thermal energy. What is thermal energy? In name, what is thermal? Thermal means heating. What is meaning by thermal energy? Thermal energy is the energy of body arising from motion of its atoms or molecules. What is student here? What is mean by thermal here? Thermal means heating. The energy is the body arranging from motion of its atoms or molecules. That is called thermal energy. It is directly proportional to the temperature of the substance. Thermal energy is directly proportional to the temperature of the substance. It is nothing but the thermal energy is measured in the kinetic energy, average kinetic energy. We know that, student, what is thermal energy? Kinetic energy Ke is directly proportional to its temperature. Ke is directly proportional to temperature. That is, it is the measure of average kinetic energy of the particles of the matter and responsible for movement of a particles. In this line you can understand, student, what is here? The average kinetic energy. Kinetic energy is denoted by Ke. Kinetic energy is directly proportional to its temperature. So thermal energy is directly proportional to the temperature. This movement of particle is called the thermal motion. What is the movement here? The average kinetic energy directly proportional to the temperature of the particles. This movement of particle is called what? That particles, what the particles are? The temperature particles is called as thermal motion. Okay, student. Next, look at this, student. What is the next one here? Intermolecular forces versus thermal interaction. The what is here? Intermolecular forces versus thermal interaction. We know that what is the intermolecular forces and what are the thermal forces. Here, intermolecular forces tend to keep the molecules together. What is, students, here? Intermolecular forces to keep the molecules. All the molecules are combined. That is, the intermolecular force is binding with the molecules. But thermal energy of the molecules tend to keep them apart, leave the molecules. Here, look at this. Here, gas to liquid and liquid to solid. In this side, here, these are moving in the forward side. Here, look at this. The predominance of the intermolecular interaction. Intermolecular interactions are moving on the forward side, and thermal energy is moving on the backward side. That is here. In a intermolecular forces, what are the forces here? The gas molecules tends to liquid, liquids to solid in forward side. In a thermal energy, here backward side, solid to liquid and liquid to gases. That is the intermolecular forces versus thermal interaction. What is the intermolecular forces versus thermal interactions? The intermolecular forces are to keep the molecules together. That means combined with the molecules each other. And thermal energy is to leave the molecules and to keep them apart. In a intermolecular forces, interaction is moving on the gas to liquid and liquid to solid, moving on the forward side. In the thermal energy, solid to liquid and liquid to gas side. That is the backward side. And the next one is student, the gas state. Important the terms of the gas state here. What do you mean by gas state? The collection of atoms or molecules whose space depends upon temperature is known as gases. Here, look at this. What student? What is the gas state? The collection of atoms or molecules. What is here? Collection of atoms or molecules whose space depends on temperature. You can understand, student, what is here? The collection of atoms or molecules whose space means universe, is depends of the temperature is known as gases. Here, characteristic of gases. What are the characteristics of gases here? Here, look at this: pressure and volume and temperature, and fourth one is the amount of gas. What are the characteristics of gases, students? Characteristics of gases are the pressure, volume, temperature, and amount of gas. What is meant by gas state? The collection of atoms or molecules whose space depends upon the temperature. Okay, student, understand? In this characteristic, what is the first one? Pressure. We know that in previous class already we learned what is in the lower sections. What is mean by pressure? Pressure P is equal to F by A. That is the, what is the definition here? Here, look at the definition, student. Pressure. The force is exerted by the gas on per unit area of the walls of the container. Here, look at the students here taking the wall. If these are the gaseous molecules, what is there? The force is exerted by the gas on unit area of the walls. These are the walls of the container. What is your definition? The force is exerted by a gas on unit area of the walls. What is your pressure is denoted by P. That is formula is pressure P equals to F by A. What is mean here? F is the force and A is the acceleration. What is here? Force. P, pressure is denoted by P. P equals to what is the formula? F by A, where F is the force and A is the acceleration. Okay, student, what is pressure? The force is exerted by the gas on per unit area of the walls, that is the container, walls of the container. Here units, very, very important, student, units of the pressure. What are the units here? SI units is Newton per meter square or Pascal. What are the units of pressure? Newton per meter square or Pascal. Another units of pressure. The pressure is measured in the, we are taking the atmosphere. 1 atmosphere is pressure is equals to 10 to the power 5 Pascal. You can understand, student, what is the atmosphere? 1 atmosphere is the, what is ATM means atmospheric pressure. 1 atmosphere is equals to the 10 to the power 5 Pascal. In mm of Hg, Hg means here mercury, mm of mercury. 1 atmospheric pressure is equals to 760 mm of mercury. In centimeter, 76 centimeter of mercury. What is the second units of pressure? Mm of Hg. 1 atmospheric pressure is equals to 760 mm of mercury and 76 centimeter of mercury. You can understand, student, what is here pressure? What is the definition of pressure? The force is exerted by the gas on per unit area of the walls of the container. That is called pressure. Pressure is denoted by P. What is the formula? P equals to F by A. Here, what is mean by F? F equals to force. What is A? A equals to acceleration. What are the units of pressure? SI units. The pressure SI units is Newton per meter square or Pascal. Another units in pressure is measured in the ATM, that means atmosphere. 1 atmosphere is equals to 10 to the power 5 Pascal. In mm of Hg, 1 atmosphere is equals to 760 mm of mercury and 76 centimeter of mercury. What is the second characteristic? Volume. What is mean by volume? The space between the gas molecules. What is here volume? Here water vapor, that is the vapor means volumes here. The space between the gas molecules is called volume. Volume is denoted by V. What are the units? The SI units, the volume SI units and meter cube. In liter, 1 liter is, we know that 1 liter equals to 1 decimeter cube. In ml, 1000 ml. In centimeters, 1000 centimeter cube. In cubic centimeter, 1000 cubic centimeter. What is the volume, students? The space between the gas molecules. What is here? Space between the gas molecules, that is called volume. Volume is denoted by V. What are the SI units? It is meter cube. We know that 1 liter equals to 1000 ml. In centimeter cube, 1000 centimeter cube, and cubic centimeter, 1000 cubic centimeter. That is the second one characteristic of gases. What is the third one? Temperature. Spotlight. Okay. Let's look at what is the third characteristic, temperature. Here look at this temperature. Degree of hotness or coldness of a body is called temperature. Here look at this, student. What is meant by temperature? The degree of hotness. Hotness means heat, or coldness of a body is called temperature. We know that temperature. Okay, student. Temperature is denoted by T. What is the definition of temperature? Degree of hotness or coldness of a body is called temperature. The temperature is measured in the Kelvins and Celsius and Fahrenheit. All three are we are already known. What is the temperature measured in? Kelvin scale and Celsius degrees and Fahrenheit scale. We know that formula, temperature, the conversions of the temperature by using the formula, you can understand, student, and very important, this formula. You remember that formula. What is the formula? Where C by 5 equals to F minus 32 by 9. Okay, student, what is the formula? C by 5, that equals to F minus 32 by 9. Here C is the Celsius degree, where F is the Fahrenheit degree. Here look at this, student. We know that the Kelvin temperature, TK, Kelvin temperature is denoted by TK. K means Kelvin, where T is the temperature. Kelvin temperature equals to 273.15 plus T degrees centigrade. What are the Kelvins? In Kelvins, the temperature here 273.15 plus T degrees centigrade. You remember that this equation, student? What is the TK? Kelvin temperature. What is the Kelvin temperature? The value is 273.15 plus T degrees centigrade. Here unit conversions of temperature, student. What is first one? Fahrenheit to Celsius. What is here? Here Fahrenheit to Celsius. That is Celsius, degree Celsius equals to 5 by 9 into F minus 32. Here look at this, student, formula. What is here? Fahrenheit to Celsius. Here we know that, we remember that the Celsius C equals to cross multiply 5 into F minus 32 by 9. That is the year. Fahrenheit to Celsius. Okay, student, here look at this. Celsius degree. Here C is the Celsius degree. and cross multiplying, 5 comes to this side, 5 into F minus 32 by 9. That is the Celsius degree. What is the formula here? Fahrenheit to Celsius, C degree centigrade equals to 5 by 9 into F minus 32. And second conversion, Celsius to Fahrenheit. What is here? Celsius to Fahrenheit. Here look at this in this formula, Fahrenheit F. What is here? Cross multiplying, that is 9 comes to this side, 9c by 5. Here minus 32 comes this side, plus 32. Okay, students, here look at this Fahrenheit degree centigrade. F degree equals to 9 by 5 degree centigrade plus 32. How to come this equation here? Look at this formula. In cross multiply, 9 comes to this side, 9c by 5, that equals to F minus 32. This minus 32, we remember that we can find the value of F. F equals to minus 32 comes this to this side, that is the plus 32. What is here? Celsius to Fahrenheit equals to Fahrenheit degree centigrade equals to 9 by 5 degree centigrade plus 32. That is the Celsius to Fahrenheit. Next, Kelvin to Celsius degree. What is, students, here? Kelvin to Celsius. Here Kelvin, how to find the Kelvin? Kelvin degree equals to C degree centigrade plus, what is the value? Basic value. It is the temperature. Basic standard temperature value. What is here? 273.15 is called the standard temperature. 273.15. Here what is? Kelvin to Celsius. How to calculate the Kelvin value? Kelvin equal to degree centigrade plus 273.15. And next, Celsius to Kelvin. How to find out the Celsius here? Celsius degree, C degree equals to, here K minus plus 273.15 comes to this side, K minus 273.15.
Sir, close the session, sir.
Sir?
Close the session, sir. Okay.
Okay, thank you, sir.
Ah.
ఏదండి ఇది కింద